The parallelogram law of addition of vectors. Okay, so let us read the statement first of all. If two vectors acting simultaneously at a point be represented in magnitude and direction by the adjacent sides of a parallelogram drawn from that point, then their resultant is represented in magnitude and direction by the diagonal drawn from the same point. Now what does this mean? Okay, it means that if there are two vectors acting at a point, maybe two forces acting at on the same body, okay, and if you can represent those two vectors by the adjacent sides of a parallelogram, all right, then the diagonal of that parallelogram drawn from that point is nothing but the resultant of the two vectors. Right? For example, let's say I have two vectors here, and these two vectors are acting at the same point A. I have the two vectors P bar and Q bar. They are acting simultaneously at point A, and I have this parallelogram ABCD. Now, if I can represent these two vectors by the adjacent sides, of course I can, is it not? So this vector is represented by the side AB, and this vector Q bar is represented by the side AD. So if I can represent these two vectors by the adjacent sides of a triangle, then the resultant drawn from this point, that means this resultant, the diagonal drawn from that point, that means that diagonal, not this diagonal. Okay, so the diagonal drawn from that same point, that will represent the resultant in magnitude and direction. Got it? So here, theta is the angle between the two vectors P bar and Q bar, and beta here is the angle that the resultant makes with the vector P bar. Okay, so again, let us find the magnitude and direction of this resultant vector. So for that, we have to do a little bit of construction. Just like before, I will extend this side and I will draw a perpendicular. From here, I will draw a perpendicular till there. Okay. Let's say this is N. Do you agree or not? This angle also will be theta, right? Okay, so first of all, let us find the magnitude of the resultant. Okay, so how do we find the magnitude? We see here that the resultant is represented by the side AC. We can take this right angle triangle ACN and use Pythagoras theorem. We will get the side AC. Okay, so in triangle, just like before, just like what we have done in the triangle law of addition, in triangle ACN, take Pythagoras theorem, you have AC square is equal to AN square plus CN square. And AC square, AN is AB plus BN, so AB plus BN whole thing square plus CN square. So you have AC square, here we can apply the A plus B whole thing square formula. So you have AB square plus BN square plus 2AB BN plus CN square. Okay, and just like before, let us find in triangle BCN. In triangle BCN, what is sine theta? Sine theta is perpendicular by hypotenuse, so that will be CN by BC. So this implies CN is equal to BC sine theta. Let's call this some equation. This will be equation 1. This will be equation 2. And similarly, cos theta. Cos theta is base by hypotenuse, BN by BC. So this implies BN is equal to BC cos theta. Let's call this some equation 3. Okay, so let us substitute. Instead of CN, we'll substitute with this, and instead of bn here and here, we'll substitute with that. Okay, exactly what we did in the triangle law of addition. So therefore AC square is equal to AB square plus BN square, but BN is BC cos. So it'll be AB square plus BC square cos square theta plus what else? Plus 2ABBN, and Bn again BC cos, plus 2AB BC cos theta plus Cn is BC sine, BC square sine square theta. Okay, so let me just cut short this step out here. BC square cos square theta and BC square sine square theta. If I take common BC square, then inside bracket I will have cos square theta plus sine square theta, and that is equal to 1. Okay, AB BC cos theta. All right, so you have AC square is equal to instead of BC, can we take AD? I think we can, no? Because this is a parallelogram, right? So the opposite sides of a parallelogram are equal. So instead of BC, let us take AD. Okay, so instead of here BC, let's take AD. So we have AB square plus AD square plus 2AB AD cos theta. This will be equation number 4. Okay, but we know very well that AC is equal to R, AB is equal to P, and AD is equal to Q. So therefore you have R square is equal to P square plus Q square plus 2PQ cos theta. So only R, that will give us P square plus Q square plus 2PQ cos theta under a root. This is the resultant vector, okay, the magnitude of the resultant, which is exactly the same as in the case of triangle law of addition. All right, so now let us find the direction number 2. Direction of the resultant. Okay, and again, the direction of the resultant. How do we know the direction of the resultant? We only need to find which angle now. This angle, beta? Yes, because if you know this angle, then you would know in which direction R is pointing, right? So let us now find beta, or tan of beta. Okay, so we take in this triangle ACN once again, tan of beta is perpendicular CN by AN. in triangle ACN, tan beta is CN by AN. So this will be CN, but what is AN? AN is AB plus BN, right? And CN here is Q sine theta or cos theta. Let us have a look. Not this. Yeah, CN is BC sine theta. BC sine theta. So CN here, that is BC sine theta by AB plus, what is BN? BN here will be BC cos theta. So tan beta here is what? BC, but what is BC? If you look at the diagram once again, BC, if I'm not mistaken, that is equal to AD. Yes, BC is equal to AD, okay? and AD is equal to Q, right? So instead of BC, we can write AD sine theta, AD sine theta by AB plus AD cos theta. So that will be Q sine theta by P plus Q cos theta tan beta. So this one, it gives the direction of the resultant, and if you check, it is exactly the same as in the triangle law of addition. All right, so this is also important from the exam point of view. Thank you.